Okay, year 9. So today we're going to talk about metal displacement. So you need to give yourself the title metal displacement. And then I've got the learning objective is to know how metals are extracted from metal ore. But before we get onto that, quickly now pause the video and write down the products from each of these three reactions. Okay, so those are the products that you should have got. One other question would be, how would you test to see that hydrogen was given off? And you would put a lit splint over a test tube containing the gas, and it would make a popping sound if it contained hydrogen. All right, so on with today's lesson, which is extracting metals from metal ore. So number one is, what is metal ore? Okay, that's O-R-E. Okay, and this is a rock containing metal. A rock containing metal. Now, things like iron and copper, all of these metals that we use in daily life, we can't just dig them out of the ground as pure metals, right? It'd be great if we could, but we can't. So generally, they will be underneath the ground in a rock that contains that metal, and we need to be able to extract it from the metal. All right, and we do that. There are a number of different ways of doing it, and one of them is metal displacement. Okay, so if we take a look at an example, so we could imagine that we have dug out of the ground a rock with copper in it. Okay, so that would be copper ore. So how do I get my copper from my copper ore? Well, the first thing that I need to do is I add to it sulfuric acid. Okay, and remember the formula for sulfuric acid is H2SO4. All right, now if I add my rock with copper to my sulfuric acid, what I get is a solution of copper sulfate, CuSO4. All right, so this is a copper sulfate solution. All right, well, that's great, but I haven't actually managed to get any copper yet, because now I've got this copper sulfate solution, this nice blue solution. So how do I get my copper out of my copper sulfate solution? Well, what I do is I add to my copper sulfate solution some iron. Okay, so this is iron. All right, and it's a metal and it's solid, so I just put a lump of iron metal into my copper sulfate solution. Remember, this will be a liquid, so I put my solid metal into my liquid of copper sulfate solution, and then what happens is I end up with iron sulfate solution plus copper metal. All right, so this is iron sulfate solution, and then this is the copper metal that I wanted to get. So you remember that I started with a rock that had copper in it, and I wanted the copper, so I reacted with the acid to give me my solution of copper sulfate, and I add in iron, and that gives me my copper metal, this thing here that I want. All right, I managed to extract that from the rock with copper in it. So, how has that happened? Well, you can see that here I start with copper in my copper sulfate, and I end up with iron in my iron sulfate. So what's happened is these two have swapped places. Okay, these two have swapped places. So the iron, we say here, displaces the copper. Iron displaces the copper. All right, so we have copper sulfate, the iron comes along, kicks out the copper, and the iron takes the place in the iron sulfate, and I'm left with copper at the end. All right, now iron is able to do this because, so this works because iron is more reactive than copper. Iron is more reactive than copper. So iron wants to be in iron sulfate. It's more reactive than copper, so it's able to kick the copper out of the copper sulfate, take its place in iron sulfate, leaving me with just copper metal left over. And if you were to do this reaction, what you would see is you would see the iron would slowly disappear. Okay, so that nice silvery metal would slowly disappear, and then you would start to see the formation of copper. So a darker, browner metal would start to form. Okay, excellent. All right, so let's have a go at another one. We can call this our first example. So I've got another example over here. Okay, so I know that magnesium is more reactive than copper. Magnesium is more reactive than copper. So if I've got a solution of copper sulfate, the magnesium is going to displace the copper sulfate, the copper from the copper sulfate. Okay, so magnesium displaces the copper, okay, to give me magnesium sulfate and the copper metal that I want. Remember, this is the metal that I want. Here it's in solution, so I can't use it when it's in solution. All right, but by displacing it with magnesium, the more reactive metal, I get my copper. That's what I want. Okay, and it does this because magnesium is more reactive than copper. Okay, so you have a go at one. So number 3 would be zinc metal plus copper sulfate solution. All right, and I can tell you that zinc is more reactive than copper. So what would be the product from that reaction? Okay, so the zinc is going to displace the copper from the copper sulfate solution, and it's going to give you zinc sulfate plus copper. Okay, let's do one more. So this one is gold plus my copper sulfate solution. All right, and I'm going to tell you that gold is less reactive than copper. Gold is less reactive than copper. So what would be the result of that reaction? Pause it and have a think about it now. Okay, so because gold is not as reactive as copper, it's not able to kick copper out of this copper sulfate solution. So gold is unable to displace copper. Okay, because gold is less reactive than copper, it cannot displace copper. And what that means is, over here, you get no reaction. So nothing would happen because the gold can't kick out the copper, so nothing happens. Up here, zinc is more reactive than copper, so it is able to kick it out, and you get the reaction, but here it's not able to do that. All right, so that leaves us with our first important conclusion, which is more reactive metals are able to displace less reactive metals However, less reactive metals are unable to displace more reactive metals. Okay.